So this is the course for the first group, the section 1, and then I will do the class for the second group, second section at 7 p.m. today. Is that clear? Is that understood? So we have more than 50 students at the moment. Some of you from second group, I guess. Yes, please, if you are in the second group, wait for 7 o'clock, 7 p.m. today. I'll make the class at 7 p.m. today for the second group, second section. Would it be okay for you? Do you understand what I mean? What I'm saying? No? Yes? I think it's clear. Yeah. Yeah. I will do the class for the second group. So today, never mind. Yes, you can join. You can join at 7 o'clock, 7 p.m. today. If you are in the second group, please welcome at 7 p.m. Yes, I'll do the same thing, exactly the same thing at 7 o'clock. So still 62 today. Yeah, we have some more students. Yeah, it's okay, no problem. I don't mind. But you are very welcome at 7 o'clock, 7 p.m. today. If you are in second group, please come back at 7 p.m. Okay, I'll go through. So that's the Blue Tunnel. Blue Tunnel is the project of the two basins, between two basins. One basin we have plenty of water, plenty of drinking water, and then taking all the water from the one basin to another. So that is the project of the Blue Tunnel. The name of the project is, we call it Blue Tunnel Project here. Yes. And then trenchless technology, horizontal drilling. Yes, this is also a part of the new part of the water resources engineering. So without disturbing all the crowded road on the surface, just drilling the horizontal pipe or horizontal line underground without disturbing all the traffics. You can see here traffics, and then if you wish, yes. So there is no way to interrupt the traffic, and then you can make all the pipeline, including all the water supply, wastewater collection, and then the energy transfer and communication, everything together. You can see here the line of the horizontal drilling, and drainage engineering. So if you look at here, drainage engineering, yes, which is also important for the the airport projects and then big project as well as the agricultural land. So if you look at here, so that is the distance of the lateral drain spacing, which is something like 5 meters, and then that is the slope between the starting point to end point, and this is closed drainage system. So yes, sometimes we can have the open drainage system or closed drainage system in the field. So drainage engineering is a part of the water resources engineering, because yes, because drainage is directly related to the flooding, the excess water. If you have much more excess water, so you have to remove all the water very short time and a very effective way, means of the way. So that is the idea of the drainage engineering as well as the agricultural engineering. So drainage engineering is also important for the football area, If you look at any sportive area, sportage area, yes, you can see the importance of the drainage engineering, which is much more the subject of the civil engineering. And water harvesting from humid air. So this is the much more popular, project in the hot climates. If you live in hot climates, especially in the Middle East region, so you could have this kind of water harvesting from humid air, collecting the humidity from the air and then getting the water to use it. So that is the photo. You can see the picture here on the left hand side, and this illustration on the right hand side, especially for the African countries and then the countries in the Middle East. You can do this kind of project to collect the water or harvest the water from the air, directly air. And then water harvesting from humid air. So that is the idea of the water harvesting from humid air, the collecting, that is the inlet, you can see here. We could have suction here, and which is the negative pressure, suction means the negative pressure, and I'm taking the humid air inside inside this device and then producing the water. That is the desalination. So this is the simple form of the desalination. But in the Middle East region, what we use at the moment, which is much more engineered system, much more high-tech system, so that this is not the high-tech system. So this is very simple, very basic desalination, collecting the, yes, if you put the saline water here, so you can see the saline water inside the cover. So if you have the cover on the top, so during the sunshine, so that is the sunshine, so all the water goes through the, the upper level because of the evaporation takes place, and then condensation here, condensed water collected on the both sides. Yes, that is the idea. You can see the collecting water on the both sides, and that's the water that we are taking from the desalination. So this is very simple example of the desalination system. So what it says here, desalination in Istanbul. So we are going to have desalination process to produce the potable water from the sea, and also in Izmir. Yes. So this picture says. So that's the some news from internet about the desalination in Turkey. So we could have desalination process in Istanbul and then desalination process in Izmir to produce the potable water. You know that it is not the drinking water. What we call it is that the potable water. Potable water means that the usage water, not the drinking water necessarily. And desalination by the use of solar energy. So this project is very much suitable project for your country. If you live in the Middle East region, so you can do this kind of project by the use of solar energy, so that is the very much renewable energy, so that is this recycling of the system, recyclable reuse of the water, and an sustainable development, sustainable environmental friendly technology. So if you produce energy from the solar energy, and then if you use this energy by means of the desalination of the seawater, so you can produce the potable water easily. So that is the idea of the producing the potable water from sea, so which is very good, very impressive project actually for your country. Yeah, it could be for your country. And yes, we have some examples in Turkey. The desalination, we have islands in the Marmara Sea. Have you been there? Avşa Island. Probably not. Yeah. You know the great island and then small island, something like that in the Marmara Sea. Yes. We have desalination process in Avşa Island in Turkey. And you know the water treatment, the means of the water treatment to produce the safe water, safe drinking water, and then as well as the wastewater treatment, recycling and reuse of wastewater treatment. Afterwards, if water is being treated, so we can recycle it, we can reuse it. You know the idea of the recycling of the wastewater. And water resources engineering is directly related to the oil platforms in the sea or in the ocean. So it could be suspended, it could be cable, you know, the connection of the cable, it could be suspended, it could be directly based on the main rock under bottom of the sea, something like that. So we have a kind of oil platforms. So this is very much engineered oil platform, which is the subject of the water resources engineering. So the problem here, the kind of problem is the wave action. So what kind of wave action that we expect here, and then what is the you know, the quality of the concrete, quality of the material, everything together here. And dam project, yes, hydropower energy. So we are going to move to dam project, starting from the project of the dam, design of the dam, and then construction of the dam, and as well as the operation of the dam. So in this course, we have some length of the weeks for the dam, because dam is important. Dam is important for Turkey, dam is important for your country as well. So this is another, you know, the type of dam in Turkey. In the middle of Turkey, yes, we could have this kind of valley. You can see the valley here, very narrow, and then if you put the dam between the two sides of the rocks, so yeah, that's very impressive dam project in Turkey. And this is very famous dam construction in Turkey. You probably know that from Discovery Channel. If you follow the Discovery Channel, so you can see this kind of Yusuf Ali dam in Turkey. Very big and very large dam. So you can see here all the construction machines transferring by the the crane one side of the dam to another side. So hydroelectric power plants. I'm gonna give you some information about the hydroelectric power plant. So how to work the hydroelectric power plant, and then the design of the hydroelectric power plant, operation and maintenance. And underground dams. Nowadays, if you notice that all the news, everyone says, yes, we have to build underground dams rather than the surface dam. You know, many dams that we have in Turkey are constructed on the surface of the earth. What about this? That is the underground dam. So there is no way to see the dams with your eyes because of the construction on underground. So that is the idea. All the news in Turkey, yes, they are saying because of the drought, water shortage, if you have the less water, so you have to build, you have to construct underground dams, something like that. You can see all the news. And suspended bridge is also related to the water resources because of the wave action or coastal engineering, something like that. So you could have this kind of project in your country that we have in Turkey, and so that is the Sweden one bridge, which is, yes, very much related to the water resources engineering. So what about this? This is also evaporation control. If you have the storage place or the dam reservoir, so you have to keep the much water inside the storage system. So that at that time, so we have to reduce the evaporation by use of this kind of what is that? It's the black balls. Black ball. Millions and millions of the black ball to reduce the evaporation just put on the surface of the water. Rubber dam, which is removable. So that's the mobile dam, something like that. Yes, it's not the constant position. So, we don't have any concrete or any solid material. So that is the rubber dam. Sometimes you have to move it, throw it away, and then if you have the raise of the water, plenty of the water, you can use it, rubber dam. And so that is the operation of the rubber dam. Do you have rubber dam in your country? I have no idea. In your country, what about in your country? Yes, we have in Turkey rubber dam. So that is the something like below. Yes, rubber dam to control the water level inside any canal or any channel, anything, so any waterway, so you can control it. And then to construct the airports in the sea. So what we call it an artificial island or artificial airport for filling the sea to gain the land and then to build the airport. So yes, in Doha, in Qatar. So airport is also same as this. Yes, on the sea. The airport, the way of the airport on the sea in Qatar. So have you been there? Qatar, Doha. So that is the project. That's the level of the project of the airport inside the sea, which is Black Sea. And then you can imagine the regime of the Black Sea, which is very much, dangerous. Deep sea discharge. So what we are discharging with this pipe to the sea, we are discharging something to the sea by use of the pipeline. So what we are discharging to the sea here? An idea? Do you have an idea about this project? No? Treated water. Treated, yes. Discharging from wastewater treatment plant. Deep sea discharge. Yes, what we call it deep sea discharge, which is very much related to the water resources engineering. And in the past, the Panama Canal is directly related to the water resources engineering, which is the very good example of the water resources engineering. And Palm Island in Dubai. You know the Palm Island in Dubai, yes. This is the artificial island. Artificial island, man-made island, Palm Island. And this is also in Dubai. This is the first one, Palm Island. That's the second one here. And this is the map of the world in the sea. Yeah, global island. Yeah, they are all the project of the artificial island inside the sea. And if you remember breakwater, so in the coastal area, you can see this kind of breakwater to keep all the, the floating objects inside, and then this is also some kind of breakwater in United States, something like the scientific arts, Salt Lake. So this is the picture from the Salt Lake from United States. The wave breaker. That's right, exactly. Breakwater, wave breaker, and waterways. Some high-tech waterways, from Germany. You can see this kind of picture, waterway, and that is the bridge, also bridge, and then it's also waterway. So everyone is looking at this, ships and all around. Wave and level control. So this picture from Netherlands. Yes, to keep the inside the water here, because the level of the Netherlands is much less than the water level, the sea level. So that is what they are doing here, controlling the seawater and then the river water by means of gate, which is removable gate. And this is very much, the basic wave level control mechanism. And this is also wave and level control by used car, yes, car tires. If you use the used car tires, so you can make this kind of wave control. So that is if you remember something we have in the fluid mechanics, Archimedes principle. So this is the action of the Archimedes principle. During the flooding, if you have the flooding just reaching the water level somewhere here, so all the water goes through in this compartment and then rise the wall, and that is the this is the wall, the red one here, and this is the actual picture here, what we call it wave control. Wave control, yes, these two gentlemen keeping away from the water. So that's it's something like the balancing of the two tanks, Archimedes principle, the means of the Archimedes principle. Wave control, you can see here the wave control, two compartments together. If you have the water in the first compartment, all this wall goes up like this, so you can keep the buoyant house. So that is the condition of the house, what we call it the normal condition, and that is the condition of the house during the flooding. So flood control, flooding management by means of the house. You can see here a swimming house or floating house, like floating dam. Yes, exactly. And also the floating house, which is directly related to the buoyant force. You can generate the buoyant force here to keep this house or this construction swimming or floating. And floating house, this is the example of the floating house, or hotels underwater. Maybe in the future we can see this kind of hotels underwater. Now there is one in Japan, hotels underwater. Yeah, hotels underwater is also subject of water resources engineering. And underwater city, Japan, yes. If you remember what I told you at the beginning of the course, just imagine. You can make your imagination, or you can improve your imagination about the water resources engineering, water resources system. So this is the idea of the underwater city. And what about this? Edible water balls. Maybe in the future we are going to have this kind of edible water balls. Then you can see the edible water. Yes. So this is also edible water. And if you remember, Water Revolution 4, what it says, yes, we have to take the water from the sources and then use it again and again and again. So that must be the recycle or reuse of the water. So that is the idea of the Water Revolution 4. And also Transatlantic Tunnel. What it says, Transatlantic Tunnel, travel from London to New York. It takes only 54 minutes, 8,000 km per hour, in a vacuum tunnel, some of them under ocean, some of them on the land. So it could be, yes, it could be possible in the future. Why not? Transatlantic Tunnel. So that is the project of the idea of the Transatlantic Tunnel. And this is the end of the introduction section, my friends. That's all today. Thank you very much for joining us, and then I'll see you next week. Please be sure for your section, and then if you are in first section, please connect at 4 p.m. If you are in the second section, please connect 7 p.m. So I'm going to do the same class at 7 o'clock for the section 2, group 2. Okay? Thank you very much. Thank you for joining the class. Take care of you. I'll see you. Have a good day. Have a nice day. And then bye-bye.